Okay guys, I'm just going to go for this. I apologise for the bad technology here, but limited time. I bought one of these about a year ago actually, and I'll be honest, I wasn't very impressed. It got flung to the corner of my workshop for a while, and it got left there, and then I had a couple of weeks off work, and I thought I'll just go back to this and I'll see what I can get, and I'm pretty impressed. I mean, 40 quid's worth of stuff, you know. So I mean, let's be clear. It's not gonna replace the it's not gonna replace an oscilloscope, but for hobbyists, I'm quite happy. So it's like inside, guys, showing you this because there are two different versions apparently. You can see, I know the picture's rubbish, but you can see with the chip layouts which version I've got, and here in the top right hand corner here it says it's got the model number LHT00SU1-V1_3. So that's the model I've got here, and the news I'm going to shed here is that it does do signal generation. Yep, I know that when you look on the net it says it doesn't. All the adverts say it does, but any information I can find on the net about this little box says it doesn't do signal generation, but it does. Now it gets a little bit complicated, guys, because most people are going to want to use something called PulseView software for this. It's an open source program, free to download, no issues with that at all. Good little program. It doesn't allow the signal generation to work though, and it doesn't do live oscilloscoping. And I use the word oscilloscope as quite loosely really, because it's never going to replace an oscilloscope, but it'll give you an indication, and it's quite accurate. You can calibrate through the USBee software. That's B as in the buzzy bee, USBee software. Then you can get live oscilloscope type data, albeit a bit slow, but it can be calibrated, and it really is quite accurate, really. But like I say, use the word oscilloscope, loosely, because it's not awesome. Anyway, let's get straight into it. It's a little bit difficult because PulseView and the USBee software use two separate drivers to talk to this, and they're sort of not you can't use both at the same time. I have found a method of being able to set one USB port up, so when you plug this into it, it wants to work on PulseView, and you use a different USB port and it wants to use the USBee software. And that's what we're going to try and talk through here today and get that working for you. First, before we go to that, because that's a little bit complicated, I'm just going to show you a little bit of the tools that we can use. I'm going to do the USBee tools first because it's the signal generation that people say this can't do, so I'm going to cover that first, because maybe you use this anyway, and no point listening to the whole video if you use this anyway and you use it through PulseView. You're probably okay with that. We'll do the USBee software first, then signal generation and live oscilloscopes, and then we'll move on to PulseView, just in case you've not seen that. There is one good video on YouTube about PulseView. Okay, without further ado, because we're 4 minutes in already, I need to speed that one up, Kev. Maybe let's see if I can record it. Maybe not. If not, you've got the full length video. Okay, guys. So first thing we're going to need to go and get the software, and we're going to go to the usbee.com download.htm site, and you're going to come here. Now the first thing you're going to do is, or the first thing you're not going to do, is get really confused about this USB suite for the AX, which is what we've got here. We're going to ignore that. It's an updated version of the software, but in all honesty, you're going to want to use PulseView. So we're just going to ignore that. I'm not going to go there. What we are going to do is we're going to scroll down here and get this USB AX Standard, Plus and Pro software. Download the 32-bit, 64-bit, whichever computer you've got. And you notice here we've got signal generator, and we've got the oscilloscope part here. We've also got things like pulse counters. We've got I2C and frequency generators. We've got quite a host of. If I'm honest, I think we're just going to concentrate on oscilloscope and signal generator here because, as you know, as I said before, signal generation, people think it doesn't do it, and it can. So let's do that. I'm not going to show you how to go through the steps of downloading Now you're clearly pretty technical. You're watching this video, so you just install it. It's the next thing. We don't need to worry about it too much. The bit we do need to more worry about is when we come to plug it in, and especially if you guys have been using PulseView. If you've just bought this off the internet and it's just arrived today, you're watching this video, you've just installed this software, this bit's going to work. If you've been using PulseView, it may not. We're going to cover that bit later of how to get it to work. But that starts to get more technical, but it can be done. We're gonna plug in. First of all, before I plug in, I'm going to start up Device Manager. So Device Manager, just press this on the start button there. Start typing Device Manager, and we want to see the USB bus controllers here. I'm going to just scroll this down a bit so it gives me a little bit more room. What we're wanting for this software to work, for the USBee software to work, this is really critical, so listen to this bit, guys. You're wanting it to appear as a USB serial bus controller. Like this. It's under here, it's in the controller section. If it comes up as USB serial bus device, that is because you've installed the Zagdig software for PulseView, and that's what makes this confusing. We'll talk about how to get around that later and make it so you've got one USB socket for the USB software and another USB socket on your laptop for the PulseView. We'll do that in a bit, but for now we've got it here. We've installed the software, so let's look down here, and this is it, USB AX test pod. I'm going to scroll down here, and first of all we're going to go into signal generation, because that's the bit that maybe some people have come here to see. So we're going to go into signal generator. Now if this bit hasn't worked here, while this is loading, if this bit hasn't worked here, then you'll not get a pod number here. It'll come up demo. If it comes up demo, this is your problem. We'll cover it we'll cover it later. Just be aware that when we solve this, we have to reload the program, because it's not clever enough to understand that there's a new pod number being added. You've got to add the device and then start the program. Okay, so yeah, it's looking a little bit 2005-ish with the old graphics and things, but it works. What we're going to do is a little bit of a program here. Ignore this bit at the top, because this is for the oscilloscope part. And yeah, forgive me for the programming, guys. It's just trying to prove a point that we can create a signal generation. I accept that this program takes time to run, and therefore it will not be 100% accurate. Blah blah blah. But what I'm trying to demonstrate here is that we can use this program here to set say a clock pulse going, and we can use that to clock our electronics on the breadboard. So if I click this button here, and let's just say we do a frequency, we're in hertz. Let's just put 1 hertz, nice and simple. There you go, we've got a nice 1 hertz clock free pulse up here. You notice I've got my COM port 13 running here. That's connected to an ESP32, which is running this program. And literally what it's going to do is going to read pin 16. Just wanted to jump in here and show you how I've got this connected. So I've got a ground connected, and I've got digital pin 1 connected to pin 16 on the ESP32. Simple as that. And it's just going to literally every time it goes from low to high, it's just going to time it and print it on here. So let's just try running that. If we click the generate button here, it'll generate and start printing. I'm not connected here, so let's just stop that. Connect my controller up and click generate, and there we go. So we've got, as you can see, every half a second, because we did a 1 second, a 1 hertz pulse. Every half second it swaps from low to high, and then back to low again. So that's working. We'll just prove that we're not cheating. We'll change that to a 5 hertz pulse, make it a bit quicker. You can see the pulse. Do that, and you can see it's much quicker. So I think that's and I could connect that wire from digital pin 1 on the logic analyzer to a resistor LED circuit, and it will make the LED flash. Okay, so let's just cover this off. So I've got the digital output pin 1 on that ground wire going to a resistor LED circuit to ground. Just nice and simple. Just cover this off. I've got my 1 hertz pulse, and I click generate, the pulse, the LED starts to flash, 1 Hertz. And if I stop that one and I change that to 5 Hertz, like that, create clock, close, and get ready to click generate, and I get a much faster flashing LED. So I think that covers that off. So okay, so that's it. We've done signal generation. I think we've covered that off quite well. I don't think we need to spend any more time on that. You can practice, play around, read the manual, see what else you can cover from that. It's a little bit rubbish. I'll tell you what I need to do in here. It needs reverse engineering to see what's actually this program sending to the logic analyzer to get it to perform this signal generation, and then we could rewrite this program, I guess, and make it so you could do clever things with it. But anyway, that's what we have so far. The other one we want to just cover off is the oscilloscope part, which I quite like. Again, using the term oscilloscope loosely. I'm not using this mixed signal on. This mixed signal on runs so slow, it's unbelievable. In fact, well, it's almost unusual. So, if you're going to do this, you would use PulseView. But the oscilloscope one, as a standalone package, is better. It's functional. It seems to reasonably follow what you're trying to ask it to do. So this is this. So for this, we just need to alter the pins. So I've got the brown now on the analog channel 1, and that goes over to pin 25 on the ESP, and the white one on analog channel 2 on pin 26 of the ESP32. We're going to look at my program here, and what we're saying here is we've got on the digital analog converter 1, we've got an output of about 10 kilohertz. We can see that it's running live. If I stop and click run, if I click this auto setup, sometimes it gets it right. There you go, it's got it right. Okay, and this is the incoming wave that we've got, and we can see it's reading about 10.6, 10.7 kilohertz. So, and I've got a multimeter here, and I have tested this. Although my program here says 10. Bearing in mind I'm using just this library file here, so I'm not sure how accurate it is, and there'll be all sorts of things in play here. But so I've put 10,000 here, so you'd expect it to be 10,000, but I'm pretty sure that this is it's the programming's fault rather than this device's fault, because if I use my multimeter and put it on the kilohertz setting and measure it, then that is pretty accurate. That's really what it's coming to. We can also stop this, and we can just do like a single read, and we can do some measurements. Left mouse click, right mouse click. But I'll be honest, if you're starting to get to this sort of level, you're probably going to want to switch to PulseView. The beauty about this is that over PulseView is that you can do both channel 1 and channel 2. So if, for example, I put a lead on analog channel 2 from the logic analyzer and stick that onto, if you look at my program here, if you see it says digital analog to converter 2, we've got a 1.3 volts on there. So if I plug that into pin 26 and I go to channel 2 and ask it to do a single read, in fact no, I'll make it run. There you go. If I run it, and it's coming out at 1.33 volts, which is actually right when I do that on my multimeter. It's actually about 1.33 volts, so I'm quite happy with that. That seems to work. It drops down to 1.25. I'm quite pleased with that. We can stop that. We can run a single, and we can start to zoom in a bit, and we can see the thing. But again, if you're going to start doing that as a reading, you're probably going to want to go to PulseView. So I think out of all these programs, the signal generator and the oscilloscope part a good complement set of programs to go with PulseView. You might find something with these, you know, by all means, you know, try them out, see what you think. But these two are the ones that I can see, and then I would generally jump onto PulseView. So let's look how we make the port work for PulseView and the port work for USBee. Just me here from my future Kev. I was listening back to that and realised I didn't cover calibration. Worthwhile, guys, calibrating using this here. Shall I do it? Shall I not? No, not bother. It's so easy. It just follow what it says on the screen. You connect analog channel 1 and 2 to ground. Press OK, then it asks you to connect the 9-volt supply to both analog 1 and 2. You do that. It then asks you to check that on a multimeter to check what the exact voltage is. You type in the exact voltage, press OK, and then it tells you calibration complete. It did make a difference, guys. It made these more accurate, so well worth doing. But it's no point walking you through that, because it's pretty easy, really. Okay, back on with the video. Okay, guys, so let's just cover off where to get PulseView from. So this is the SIGROC page, and if we go to the downloads, and I'm going to use the Windows, and I'm using this version here. And again, guys, I'm not going to go through all the next installation. It's just pointless. That bit's easy. So install that software there, and then once you've done that, you come down here and you've got the SIGROC here, and you've got PulseView. Now, when you first do this, if you've been following this video at least, your device manager set here, so you've got a USB controller here. So if you try to start PulseView, just cover that bit a little bit more slowly. So I'm currently got this here, and it's under USB controllers, not devices. So let's just see what that does, just so you can recognize when you've got this particular problem. So if I go down here and I go here and I start PulseView here, you'll notice it says no device up here, and there's a list of things you can mess around with this, but it's not going to work, guys. Trust me, it's not going to work. So cancel that. Okay, I've got no device. Okay, let's close that out. This is because the next thing you have to do when you install PulseView is you have to open up here, and you see something called Zadig here with PulseView in the brackets. PulseView in the brackets is different. It's a different program, if you like. So just be aware there is Zadig for other applications. You need this particular one. Okay, so we're gonna. Okay, so you might get a warning pop-up saying that the certificate is not valid or whatever, but this is fine. It's used for many applications. This program. So yeah, just select yes, and to allow changes to your computer, and it will come in here. Now the bit missing on nearly every instruction, it made me stumble before, so I remember it. You've got a options, list all devices. So you get all these here, and then we want to drop down, and we want to make sure we've got our USBee AX Pro. Make sure it's obviously plugged in. Your logic analyzer is plugged into a USB port. Click on here. And what this is basically saying is it's going to place this driver into this port here. Now you're going to click replace driver. I'm going to do it. I've done it a few times already, so I've got multiple drivers now on my system, but not to worry. You're going to see that multiple drivers in a minute when we show you how to configure different ports for the PulseView and a different port for USBee software. Let's just go for it. Just watch this down here, guys, as this starts to install, and you'll see what it's going to do. It's going to change from a controller to a device in a minute. This port. There you go. There's it gone. Look. Okay, and it does take a little bit of time to finish its job. Not quite sure, because it seems to have finished its job, but it just sits here for a while. But this is the significant part, guys. Is when it's in this as a bus device, you can use PulseView, but you can't use the USBee software and when it's in as a controller, you can use the USB software, but not PulseView. And what I need to show you is how you make it so one of your ports on your laptop PC, you plug it in and it appears up here, and the other one it appears in down here. Okay, so that says it's successful. We can close this now. We're finished with it, no problem. If we go back now into here and we go to get this here, and then we go into PulseView, you should see it should now change this. I'm going to put that back on quickly if we can. It loses it back in, and look what it's done. It's got changed the device to the what PulseView calls the firmware FX2LAFW, which is the one you need to read this particular device. It's just sort of a generic firmware, if you like. So here we are, and you notice up here now you've actually got this CWAV USB AX device connected here, and it will now run as you want it to. So probably not going to go into much about PulseView. I did say there was once you get to this stage, there's a good video about PulseView already on YouTube. Can I quickly just find that? YouTube.com PulseView. Oops, PulseView Logic Analyzer. There you go. And I believe it would be. In fact, there's quite a few actually looking at it. Yeah, I think it's that one I watched. So this is actually quite a good. As you see, there's quite a few videos for PulseView, and this one's actually using this particular logic analyzer. So I'm sure it's that one I used. That's a very good video to watch now of how to use PulseView and how to get it to do the different, selecting these different decoders and that. So I'll leave that to that guy. No point reinventing the wheel. This video is more about how do I use both. So let's now work out if I move. Let me just close PulseView. I'll just demonstrate that we can no longer use the USBee software. I go in here and I go to I don't know which one do we have. Let's go into signal generator. You'll see I've got demo number. It's lost that pod number. Remember how I said, if it's not right, this bit you'll get no pod number. It doesn't matter which. Now if I move my USB out of that socket into the other socket by installing that Zadig software for PulseView, it just overwritten everything. So I'm plugged into a port, and I want to make this port that it's plugged into now. I want to make this one for use with the USBee software. So I'm going to right click and I'm going to select update driver. I'm now going to say browse my computer for drivers, and I'm going to. I don't think it's not necessary to put that in there, but just in case, put it in anyway. Let me pick a list of available drivers on my computer. Now I've studied the info record file, so technically the bottom one should be the USBee driver. It should be. If not, try them all. As you see, I've installed the PulseView ones several times, but it should be this one because when you look at the info file for this one, it says it's an update to this, so it should be. So the lower version should be at the bottom. That's my understanding anyway. So I'm going to select that one and I'm going to click next. The Windows has successfully updated your drivers, and when I click thing, it goes back up into this. Remember what I said? Controller. If it's here, I can use the USBee software. So we go down here. Has it gone? USBee test pod and signal generator. As it loads, remember I said you've got to restart the program, get the device in the right place, and now it's got the pod number. If I load in, I'm going to start using these up here, guys. It's quicker. PulseView, load in PulseView. I've now got no device again, but and ta-da! I unplug my USB device out of that port and put it back into the another port, and voila, it's now here. If I start up PulseViewer, you can swap the port over to the right firmware. and it will detect it. So we now have a port for PulseView and a port for USB. I hope that helps. Let me know in the comments if I missed anything. Maybe you've found some better software for the signal generation. Maybe you found some better software for the logic analyzer. So if you have, please put it in the comments, because I've not found anything better than this for this solution. So yeah, I hope this has been helpful, guys.